In this video, we're going to focus on two column proofs with parallelograms, isosceles trapezoids, rhombuses, and kites. So let's say this is A, B, C, D, and E. So given the following information, let's say ABCD is a parallelogram. Our goal is to prove that segment AE is congruent to CE. So let's make a two-column proof. Statements and reasons. So let's start with the first statement, and that is that ABCD is a parallelogram. And so that's given to us. Now, in order to prove that AE is congruent to CE, we need to show that these two triangles are congruent. So notice that we have these two vertical angles. So we could say that angle BEC, and that is this angle here, is congruent to angle DEA. And so this is DEA. And the reason that we could say that is vertical angles are congruent. Now let's move on to number 3. Since we have a parallelogram, the opposite sides are parallel. So we can make the statement that BC is parallel to AD. And the reason, opposite sides of a parallelogram are parallel. Now, because they're parallel, these two angles must be congruent. Whenever you have two angles in between two parallel lines, these are known as alternate interior angles. The alternate interior angles are congruent anytime you have two parallel lines. So we could say that angle ECB, which is this angle, that's congruent to angle EAD. So this is EAD, which is this angle. And so the reason for this, we could say that if you have two parallel lines, then the alternate interior angles are congruent. So now let's move on to step 5. We could say that BC is congruent to AD. And it's based on the fact that we have a parallelogram. So we can write for step 5. Opposite sides of a parallelogram are congruent. Now let's move on to step 6. So now we could show that these two triangles are congruent. And to do that, we can use the Angle-Angle-Side Postulate. So let's make the statement that triangle BEC is congruent to triangle DEA. And this is based on the Angle-Angle-Side Postulate. And to prove this, we've used statements 2, that was angle BEC, statement 4, ECB, and 5, proving that BC is congruent to AD. So now in the final step, we could say that AE is congruent to CE based on CPCTC. Corresponding parts of congruent triangles are congruent. And so that's it for this particular proof. Now let's move on to our second example. So this time we're going to use an isosceles trapezoid. And let's draw the two diagonals. And let's call this E. So in this problem, we're given that ABCD is an isosceles trapezoid. In addition to that, we're told that angle BAE is congruent to angle CDE. What we need to do in this video is we need to prove that AE is congruent to DE. So let's try this. So as always, we're going to start with the given statement. And that is that ABCD is an isosceles trapezoid. Now, what should we do next? What's our next step? We could focus on the second given statement, and that is that angle BAE is congruent to angle CDE. And so this is BAE, and here we have CDE. So these two angles are congruent. Now, number 3. In order to prove that AE is equal to DE, all we need to show is that these two triangles are congruent. And notice that we have vertical angles. So we could say that angle AEB is congruent to angle DEC. And the reason? Vertical angles are congruent. So now let's move on to step 4. Now we could say that these two sides are congruent. So AB is congruent to CD. And it's based on the fact that we have an isosceles trapezoid, because the two legs of an isosceles trapezoid will always be congruent by definition. So in step 4, we could say that the opposite legs of an isosceles trapezoid are congruent. So now we could prove that the two triangles are congruent using the Angle-Angle-Side theorem or postulate. So let's say that triangle AEB is congruent to triangle DEC. And this is based on the Angle-Angle-Side postulate. So we use the vertical angle theorem in statement 3, and then this angle was BAE, so that was based on statement 2, and then this side is based on statement 4. And this is supposed to be number 5, not number 6. Now, for number 6, we can make our final statement that AE is congruent to DE. So these two sides are congruent. And the reason? CPCTC. And so that's it for this problem. Now let's move on to our third example, and that is the rhombus. So this is going to be rhombus ABCD with two diagonals. And this is going to be E. So in this example, the only thing that we're given is that ABCD is a rhombus. So with this information, let's prove that AE and CE are congruent. Actually, I wrote that wrong. Let's do that again. So go ahead and try this problem if you want to. So as always, we need to start with the given information. And that is that ABCD is a rhombus. Now, how can we show that AE and CE is congruent? How can we show this? So I'm going to focus on proving that these two triangles are congruent. If I can show that they're congruent, I can show that AE and EC are also congruent. So first, let's prove that these two angles are congruent. So they're vertical angles, so we could say that angle BEA is congruent to angle CED. Actually, I'm going to write that as DEC. And so vertical angles are congruent. Now let's move on to number 3. So we could show that these two lines are parallel. AB is parallel to DC. And the reason why that's the case is because a rhombus is in fact a parallelogram. So opposite sides of a rhombus are parallel. Now number 4. Since the opposite sides are parallel, notice that these two angles form alternate interior angles with these two parallel lines. So then these two are congruent to each other. So for number 4, we can make the statement that angle BAE, which is this angle, that's congruent to angle DCE. And so we could say that if the lines are parallel, then the alternate interior angles are congruent. So now we could show that the two triangles are congruent. But first, let's show that these two sides are congruent. So we can make the statement that AB is congruent to DC. And all 4 sides of a rhombus are congruent. So we could say all sides of a rhombus are congruent. Now number 6, we could say that triangle BAE is congruent to triangle DCE. So this is triangle BAE and this is DCE. So they're congruent to each other based on the Angle-Angle-Side Postulate, which is based on statements 2, 4, and 5. So now we can make the final statement. AE is congruent to CE based on CPCTC. And so this is AE and this is CE. So that's how you could show that those two segments are congruent. And therefore that makes E the midpoint of AC. So let's work on one more example. So we have kite ABCD with point E in the middle. So the only information that we're given in this problem is that ABCD is a kite. And with just that information, we need to prove that AE is congruent to EC, which makes E the midpoint. So how can we show that these two segments are congruent? We could show that these two triangles are congruent, or we could show that these two triangles are congruent. I'm going to focus on the upper two triangles. So let's make a two-column proof. Now let's start with our given as always. ABCD is a kite. Now what do we know about kites? For one thing, the disjoint pairs are congruent. AB and BC are congruent. AD and DC are congruent. Now since we're focused on the top two triangles, we're just going to say that AB and BC are congruent. So we could say that the two disjoint pairs of a kite are congruent. Now, step 3. What's next? The next thing we need to know is that BD is an angle bisector. So let's make that statement. So BD bisects angle B, which we could say angle ABC. And for a kite, you need to know that one diagonal, the longer one, is an angle bisector. Now let's move on to step 4. So because BD bisects angle ABC, these two angles must be congruent. So we could say that angle ABE is congruent to angle CBE. And so the reason for this, definition of an angle bisector. Now, number 5. Notice that we have a common side, BE. So we could say that BE is congruent to itself using the reflexive property. And then we can move on to number 6. So now we can say that the two triangles are congruent based on the side angle side postulate. So let's say that triangle ABE is congruent to triangle CBE. So it's SAS, and we could use statements 2, 4, and 5 to confirm that. So now for number 7, we could show that these two sides are congruent. So AE is congruent to CE. And so that's what we need to prove in this problem. If you want to, you can make you could take a step further and say that E is the midpoint of AC, because the midpoint divides a segment AC, into two congruent segments. And so that's it for this video. Hopefully it gave you a good idea of how to use two-column proofs with parallelograms, isosceles trapezoids, rhombuses, and kites. Thanks for watching.